All right, let's jump right in. Today, we're taking something you've definitely seen and probably thrown out from your kitchen, and we're going to use it to break down the entire scientific process. We're talking from that first curious glance all the way to a powerful conclusion.
We've all been there, right? You go to make a sandwich and, oh, there it is. But have you ever actually stopped and thought, what is really going on here? What are the rules behind this fuzzy takeover? Well, that little moment of curiosity, that's exactly where science begins. You know, every single great discovery in history started just like this, with a spark. It's that moment when you look at that moldy bread and you don't just think, ooh, gross. You think, I wonder why, or how did that happen so fast?
And that's really what science is all about at its heart. It's not just a big book of facts to memorize, it's a process. It's a way of looking at the world around us. We see something, we come up with ideas, and then we test those ideas to build real, solid knowledge.
And this whole process, it has a kind of roadmap. You start with a question, then you make a prediction, an educated guess. You investigate it with an experiment, you analyze the results, and then you share what you found out. Simple as that.
So, for our bread, the question is, what makes mold grow? Now, based on what we've seen in life, we can make a pretty good prediction. This isn't just a random guess. We're predicting that warmth and moisture are the key ingredients for a mold party.
A prediction is a great start, but it's totally useless if we can't test it. And to do that, we need a really well-designed experiment. We need to make sure it's what scientists call a fair test.
Okay, here is the absolute golden rule of a fair test. You can only change one thing at a time. That's it. That one thing you change on purpose is your independent variable. For our bread, the only thing we're going to change is the environment. One slice goes somewhere warm and damp, the other somewhere cool and dry. Everything else stays the same.
So if we're changing the environment, what are we going to measure to see if it had an effect? That's our dependent variable. In our case, it's easy. We're going to measure how much mold grows. The amount of mold depends on the environment we put it in. See how that works?
Now, how are we going to measure it? We could just eyeball it and say, yep, that one looks moldier. But our eyes can trick us, you know? That's subjective. To do this right, we need actual tools. Like a little grid overlay to measure the area in square centimeters, we need hard numbers, objective data. Because numbers, well, numbers don't lie.
Our experiment is all set up, and now comes the part of science that doesn't get enough screen time. It's not always about big, flashy explosions. A lot of the time, it's about patience. It's about settling in for the long watch.
And this is so important, because a lot of things in nature don't happen in an instant. They unfold slowly. If you only take one snapshot in time, you miss the whole story. It's by observing and measuring over days or weeks or even years that you can actually see the trends and patterns that lead to those huge aha moments.
So let's see it in action. On day 1, absolutely nothing. Zip. If we stopped our experiment right there, our conclusion would be completely wrong. But we wait. By day 3, we've got some tiny spots. By day 5, they're growing and connecting. And by day 7, whoa, it's a totally different picture. That long watch was everything.
So, we've been patient, we've watched, we've collected our measurements, but right now they're just a bunch of numbers on a page. The next crucial step is to organize those numbers so we can figure out the story they're trying to tell us.
And the very first thing we do is put our raw data into a nice, neat table. Just this simple act of organizing makes things way clearer. We can literally follow the days with our finger and see the area of mold getting bigger and bigger.
But let's be real, our brains are visual. We love pictures. So we take that table and turn it into a bar chart. And boom, it's instantly obvious. You don't even have to read the numbers to see what's happening. The growth isn't just happening, it's accelerating. That's the power of visualizing your data.
And now, we can finally make the call. The pattern in the data is crystal clear. Our prediction from all the way back at the beginning that the warm, damp place would grow mold faster was supported by the evidence. We did it. We turned a simple question into a tested conclusion.
So great! We figured out our one little bread experiment. But so what? How does this single investigation fit into the huge world of science? Well, let's zoom out and look at the bigger picture. Our one little experiment helps support a much bigger idea. You see, when people say it's just a theory, they're usually getting it wrong. In science, a theory is a huge deal. It's a powerful explanation that's been tested thousands of times by thousands of experiments like ours. Our conclusion is like one tiny brick in the massive wall of something like germ theory.
And think about this for a second. Our simple moldy bread is actually an interdisciplinary problem. You have biologists studying the life cycle of the mold itself, you have chemists analyzing the decay of the bread, and you have physicists measuring the exact temperature and humidity. It takes a whole team of different experts to get the full story.
And that really brings us to a crucial point. Science is a team sport. Nobody works totally alone. Our understanding of why bread gets moldy is built on centuries of work from countless other people. Every new discovery, including our little bread experiment, stands on the shoulders of giants.
So there we have it. We started with a gross, forgotten slice of bread and used it to understand the entire scientific process. It just proves that science isn't some far-off thing that only happens in labs. It's a tool, a way of looking at the world with curiosity. So, the real question is, what everyday mystery are you going to unravel next?